Hello, welcome back to Cracking the Cryptic, and yeah, a really fascinating puzzle today. So I was going to be doing a gas video today. I think the timing has come round to suggest that it ought to be a gas day, and indeed I have actually pre-recorded that gas video. However, that's going to now go up tomorrow, even though it might suggest that it's the 22nd or something. I can't remember what I said on it, because today is the birthday of the constructor of this puzzle's mother. Not that it matters, has written to us to say that his mother Carol turns 91 today, and he's compiled this puzzle as a tribute. And I think that's absolutely fascinating. So in fact, what he said was really interesting, I thought. He said that, let me just find the words. He said that my mum Carol, after Carol Lombard, turns 91 on October the 22nd, and in tribute to this I created a Sudoku with highly thematic minimal snakes and variant killer cages. So we'll have a look at that. Now, I got very interested in the after Carol Lombard bit, because Carol Lombard is the name of a movie star. And I was thinking, how could somebody born in 1932, that's pretty clear from the fact that 1932 is the thematic number in this, well, one of two thematic numbers in this puzzle. Even if you couldn't do the maths to establish that, not that it matters, his mum was born in 1932, 91 years ago. Anyway, how could somebody born in 1932 be named after a Hollywood movie star? Because surely they can barely have predated that era. Anyway, so I looked up Carol Lombard, and she was born in 1918, I think. And I was thinking to myself, well, this doesn't work, because she would only have been 14 when Not That It Matters his mum was born and named after her. So how can that have been known? And of course, it turns out Carol Lombard started acting at the age of 12 on screen. So she was known, and it is entirely genuine, of course, that this Carol was named after her. Anyway, I congratulate Carol on reaching 91. I congratulate Not That It Matters on having his mum still alive at 91. That's fantastic. My mum would have turned 88 this week, but that was not to be. And also what was not to be was the Times Crossword Championship for me yesterday. So let's just have a look at what happened. We had got to this stage. So I'm just going to give you a lot of context, because why not? You can skip through it. I don't mind. The way that the Times Crossword Championship was set up this year was there was a heat of 120 people. That got whittled down to the quickest 60 people with no mistakes for a semi-final. And then qualifying from that semi-final were going to be just 3 people to sit in front of the crowd and solve a single puzzle. In the semi-final, just like in the heat, there were 3 cryptic crosswords to solve in a maximum of an hour, but only the first 3 all correct solutions would qualify for the final. And I got to this stage in the final puzzle that I was doing with just 2 letters highlighted in yellow, 2 words highlighted in yellow left to complete. And the clue for the down word, which I've got highlighted here, was something like, I haven't got this right, it was something like celebration of 2 sides, one side each crossing the other. It was something like that. And I was really struggling with what that was about. There aren't that many words that fit here. And then I thought of the word rivalry, which sounded a bit like what was going on in the clue, with two sides struggling against each other. And when I did think of that, I then looked at the across clue, which was something like bad luck, one is missing from a variety, and realized that that could then be adversity, being defined by bad luck and then I being taken out of A diversity, which is very clever. And that V seemed to me to prove rivalry at 2 down. And I filled it in and handed it in. The situation I was in was that of about 4 competitors I thought could potentially be faster than me on the day and in the final puzzle, one had not turned up. One had handed in the first set of puzzles quicker than I did, but must have had a mistake and been eliminated. One had been quicker than I was on the first set of puzzles, and one had comfortably got into the semi-final. I was at the front of the room. I didn't know if anybody might have handed in a script behind me, and I desperately wanted to be in the first 3 to hand in. So I thought I had got to a satisfactory meaning for 2 down, and adversity looked good, and I went with it and handed it in. And then I was sitting there thinking about this 2 down space and whether there was any other word that could fit this pattern of R blank V blank L blank Y. And it suddenly occurred to me that revelry would work. And that was worrying. And then I spent another half minute thinking about that and realized that we were looking at R being one side right, L being the other, and that was being crossed by each, meaning the word every. And that was clearly the right answer. So a minute after having handed in my script, I realized I had made an error. And annoyingly, this was even before anybody else, it turns out, had handed in their script. So I had plenty of time to get that right and didn't realize it and didn't get it right and was thus eliminated. And my sincere congratulations go to Matthew Marcus, one of the aforementioned people who could beat me, who did win the competition. He, although Peter Stegel finished the final puzzle first, he had one single error on the spelling of the capital of Mongolia, which I feel is a bit unlucky. And Matthew was able to take the prize. And it was a fantastic day out, as always. Thank you very much to the organisers. And yes, of course, although I regret not winning, I didn't deserve to, and that's fine. So that's what happened in the Times Crossword. That's what happened. That's my story from the Times Crossword Championship yesterday. Matthew's was probably far more interesting, given especially that he flew in from Portland, Oregon to London to take part, and thus, by winning £1,000, effectively paid for his air travel only to get there and win it. That's a great story. And he's been second before, and he's a very, very fast solver. He often beats me on the daily submissions for the online puzzle. And I absolutely do not begrudge him winning the competition. Very well done to Matthew. And indeed to everybody who finished ahead of me, which was quite a lot of people once I had made a mistake. Now, Simon, I think, had accidentally managed to leave one answer out in the heat, which scuppered him. Otherwise, he would definitely have been in the semi-final. And that was unfortunate too. There we go, report on the Times Crossword Championship. Now, the other things, of course, we are finished with the Patreon competition for this month. The first 9 videos on how to solve that have gone up on Patreon for those $3 a month subscribers. The next set will go up in a couple of days, and that will take you to the end of the competition. And then there are some Easter egg puzzles, and we will put videos up for how to solve those as well, for our $3 patrons who get the videos for the rewards. And what else have we got going on? We've got, of course, our Line Sudoku app and all our apps, and we will be bringing you a new patron reward on the 1st of November. Looking forward to that. Now, this puzzle, of course, about Carol, mother of Not That It Matters, refers to the year 1932 when she was born. It features the number 91 regularly, and I will explain this. This is for mathematicians. So, normal Sudoku rules apply. That means we're putting 1 to 9 in every row, every column, and every 3x3 box. Each cage That's misprinted as age in the version I'm looking at, which is very confusing. Each cage has a value of 91 obtained by Horner's method. I looked up Horner. William Horner was a mathematician about 200 years ago who came up with a method for approximating the roots of polynomials. And I mean, that's something mathematicians do, so the rest of us don't have to, I suppose. Thank you. Anyway, Horner's method says that if the digits in a cage are A, B, C, D, E, in fact, let's do those with letters. So if the digits in a cage are, oh, why didn't that work? Because I haven't clicked that. There we go. A, B, C, D. What's going on now? What is going on now? B, there we go. C, D, E. Left to right or top to bottom. Then we apply this formula in the rules. The value of the cage is, the value of the cage, 91, equals A times B plus C in brackets. So let's use actual numbers and see how close I can get. 6 times 5, 30, no, that's a silly way to start. Let's do it like this. 6 times 4 is 24, plus 3 is 27. Times, oh, it doesn't quite work. I can't do that. Anyway, it's A times B plus C. You take that number and you multiply it by D, and then you add E. And in each of these cages, you will get 91, apparently. Don't know how those maths are going to work. This maths may be beyond me. I'm not a brilliant mathematician, but we will see how we go. Each cage contains a unique set of digits. So 5 different, well, each cage is a different set of 5 digits. The 6 shaded cells in the top right and the 6 shaded cells in the bottom left of the grid are each a pair of overlapping 1932 snakes. In that order, these snakes go orthogonally or diagonally from cell to cell. So we might go 1932, I suppose. Those are the slightly complicated rules of this puzzle. But if you can understand them, let's hope it provides a very entertaining celebration of Carol's life. And we are going to, I'm going to restart my clock and say the immortal words, let's get cracking. I don't know how we do that though, because I couldn't even work out in my head what a plausible ABCD is, which is terrifying. Okay, let's look at the blue cells. They may help. So we have 2 1932 snakes. Now, these digits, there are digits that have to be on the end of a snake here. So they're either a 1 or a 2. That must be right. You can't obviously connect up through these end digits. So the digits just inside them on the snake must be 9 or 3. Right, and that now we get to know what this is because it's in a row with a 3. So that's a 9. This must be a 1. We're going 1, 9, 3. And then this is going to have to be a 2. You can't put the 2 here or this can't be in a snake. So I'm going to put the 2 here. And then this snake must go 1, 9, 3, 2. And that snake's round like that. This snake's up like that. And that one is done. This one, if that is... No, I don't know. That is 9 or 3. No, hang on. I don't know which one of these two is the end, because this snake could go that way. Okay. These digits are from 1, 9, 3, and 2. That's all I've really got there. Now, has this stuff not helped? It hasn't really. Bother. I'm going to have to figure this out later. That wasn't where I wanted to be in this puzzle. Okay, but I'm pleased to have got some numbers down here. Maybe I can use these. So let's try this 3, which is the E in its cage. And that means that A times B plus C times D must equal 88 plus the 3 equals 91. Now, how can we have sum total made up from those cells times that equal 88. This can't be a 2, notice, and it can't be a 1. So this has to be 8 or 4. They're the only other single digit factors of 88. So these three either give a times b plus c equals 22, and that's a 4, or a times b plus c equals 11, and that's an 8. And then this cage will work. That's pretty complex actually. Okay, let's think about how they would give 11 with an 8 here, because I can't have a 2 or a 3 here. So these digits would have to include a 1. And then 1 times something plus that equals 11. So the other 2 digits in the column, in those 3 cells, would have to add up to 11 along with a 1. And that's if this is an 8. So they couldn't be 8, 3 or 2, 9. Oh, bother, there are 2 ways of doing it. Okay, that's not actually that helpful. Can that be a 4? And these multiply up to 22 along with... Oh, that's harder actually. That doesn't work. Because 1 times a single digit is only going to get you to a maximum of 9. And when you add another single digit, you can't get to 22. And if you don't use a 1, oh, you could use 4 times 5 plus a 2. That's the only way of doing it. And that won't work because this is all dependent on this being a 4. So this is not a 4. That is pretty confusing. Do go through that in your head again. But to get... I'm going to use some colours. To get the product of the 2 purple digits plus the green digit to be 22, which would allow this to be a 4, it couldn't work with a 1 here because you couldn't get to enough to get to 22. If you didn't use a 1 here, because you can't use 2 and 3, you'd have to use at least 4 and 5. And that multiplies up to 20. And actually, that would require a 2 here anyway, and you can't use that. So it's not done like that. It is done with an 8 here. These purples include a 1. And look, there's a 1-2 pair looking at it. So the 1 goes there. And these remaining purple and green digits add up to... oh, what am I doing? I'm losing control of everything. Those add up to 11. Purple and green, and that cage will work now. Crikey, if it's all going to be this hard, we're going to be here a while. Let's have a look at this one. 2 times 3 is 6 plus C. And then we multiply 6 plus C, which is, by Sudoku, 1, 4, 5, 6, 7, or 8. By that, there's too many possibilities here. We can't do much with that. This is tough though. Because, okay, what I'm now thinking about is this could be 3 or 9, and I was hoping maybe to rule out 3 on the grounds that it might have to use the same set of digits, but that's not true at all. You could even have this exact configuration virtually. I mean, you couldn't put a 1 there for Sudoku reasons, but you could put a 1 there, have purple here and green here, 8, 3, and as long as purple and green were the other values of 11, you've obeyed. Okay, sorry, let me think about 9 being here, because maybe that's a problem. If that's a 9, well, yes, that is a problem, right. If that was a 9, then A times B plus C times D here has to add up to 82. Now, 82 has 2 factors. It has 2 prime factors, 2 and 41. But we can't put a 2 here because of that. Now, I'm getting worried because we could put a 1 here and get these to have a result of 82 from multiplying those 2 and adding that. But I don't think we can, because these would have to multiply up to at least 73. And the only two Sudoku digits that could multiply up to more than that are 9 times 9. So this can't be a 9. Oh, that, you see, that's easier in a way. Actually, in a way, that's much easier than the work I was doing here, but it just didn't occur to me that 9 would be impossible, but it is. So that is a 3 again. Now, this must be a 2 to be on one end of this snake. And this is appearing in both snakes, so they are both ending in 3, 2 there. This is a 1, 9 pair here, but I don't know the order, although now I do. This is a 1, 9 pair in that order here, and at least we've got that snake done. Now, I can't put a 9 here because we've got exactly the same problem of making 82. Oh, have we got the same problem of making 82? No, we haven't. Oh, bother. Because we were saved here because that couldn't be a 2. Here, this can be a 2. These could have a result of 41 if, for instance, 7 times 5 plus 6 times 2 plus 9. That does work. So I don't know which way around this 1 and 9 go. And that's annoying. Anyway, let's start here now. We've got that 3 at the end. So the result of this group is... Actually, what I should do is put in little x's, shouldn't I? I hadn't thought of that. That's a multiplication there. I don't think I've got ways of putting in little pluses, but I'm going to do this. Sorry, you're just going to have to, it helps me with the formula. You're probably mathematical enough, you don't need this kind of crutch, but I do. So there we go. These are multiplying, add that, then multiply the result by that, add that, and we get 91. So here we're getting 88 again. Now, did we work out, does it apply here as it did here, that this can't be a 4? It certainly can't be 1, 2, or 3. I was just wondering if I'd given any thought to that being a 1, but it couldn't be a 1, okay. This can't be 1, 2, or 3. Now, if that was 4, these give a result of 22, but now you can't use, yeah, again, you can't use a 1, you won't get to a high enough number, and if you use 4 and 5, you'd need a 2 there. So that is an 8 again, and it is very similar to this setup. And therefore, we need a 1 in the beginning bit again, because these are only going to give a result of 11, and that 1 must go here. And now we have, well, the equivalent of purple and green there. Let's make it orange and yellow. Or orange and bright green. And those add up to 11, because 1 times orange plus green must add up to 11. So those add up to 11. They're not 8, 3 or 2, 9. They are either 4, 4, 7 or 6, 5. And this has to be the other set because we have to have different cage contents. And now where are we? Well, I can do a 9 by Sudoku. I do like it when finally I get to do a little bit of Sudoku in a puzzle. There's also a 9 in one of those cells. That's getting interesting. I'm wondering whether to try and study this cage profitably next. Bit scared of doing it. These two add up to 11 as well. In fact, they are purple and green, aren't they? Because they're the other set. And I suppose these two are orange and bright green because they're the other set in column 2. So they're all from 4, 5, 6, and 7. And I'm taking anything I can get in this puzzle because I'm still pretty confused. Maybe this is interesting. Those two plus 1, then multiplied by that plus that. No, that's not useful. Right, let's look at this one. Or this one. I don't know. Or 9. There's a 9 in one of those cells. Can I prove it's not here? I doubt it very much. 36 plus something times 2. Yeah, hang on. I might be able to prove this isn't a 9. No, I don't think I can. I think I could prove that that's a 2 if that's a 9. It can't be a 1. Maybe I just need to do a quick bit of thinking on where 1s are going, actually, because they are quite restricted, and that might help things. Oh, gosh. I don't know. Oh, we've got a 9 X-wing there. So 9 is in one of those 2 cells. Now, 9 there might be impossible. That would be useful, actually. Or you'd have 9 in both these. Now, 9 there would make this bunch give a result of 82. And that was the same problem we were wrestling with earlier. This would have to be a 2 in this case. And these would have to multiply to 40, and that's perfectly valid. Bother! 5, 8, 40, plus 1 is 41, times 2 is... Oh no, I've done the maths wrong. Good. Right, sorry, 91 minus 9 is 82. No, it's right. 40 there, plus 1 is 41, times 2 is 82, plus 9 is 91. That can work. And that is a disappointment to me. Where am I meant to get this from? There is a 2 in those cells and in those cells. This is quite restricted, 4, 5, 6, 7 or 8, which are reasonably big digits. Okay, that's true. So this, to be a 9, this has to be 4 times 9 is 36 plus something times 2, and then the something doubled plus that equals 19. Oh, there's ways of doing that. Oh. Okay, that's not it. That's not it. This one, 2 times... I mean, there's so many possibilities here, though. 3, 4, 5, 6, 7, 8. And then we're going to multiply up. Once we've added that, we're going to multiply up by that. Okay, let's think about... I was thinking about this being a 9, wasn't I? And then I worked out that there was a way of doing it. And it involved a 2, of course. If that's a 9, these have a result of 82. That's going to be a 2. And these have a result of 41. That is going to need... 7 times 5 plus 6 would do it. I think that's the example I thought of before. There are probably others. Well, there may be others. Maybe there aren't. I don't know. Well, but I wanted to rule that out from being a 9, and instead I'm kind of stuck with, what if it is a 9? Okay, how about this being a 9? I am not good with Horner's method. This is definitely the conclusion we're getting to here. Because I don't know where is the right place to limit. Oh, look, there's a 3 by Sudoku. There's a 3 in one of these cells. Oh, that's interesting. Then there's a 3 in one of these cells. Right. Now, maybe this is the place to focus then. Yes, okay, that's better. So if that was a 9, to give an 82 result from these cells, that has to be a 2 to give a 41 result from these cells. And that would have to be a 3 by Sudoku, giving a 38 result from those 2 cells, which is impossible. So that is not a 9. That is a 1. That is a 9. Gives me a tiny bit of Sudoku, and it finishes off the snake up there. Now, this group has to give a result of 90. Now, which individual digits are factors of 90? There's quite a few of them, unfortunately. 2, 3, 4, 5, and 6, I reckon. So, let's start with 2. Then these would give a result of 45, but that would be a 3. Now, that does work. 7, 6 there, 3, 2, 1. If that was a 3, these would give a result of 30. 7, 4, 2. I mean, there's lots of possibilities, because I think I saw one with a 6 there as well. These would give a result of 15 with a 3 there. Actually, maybe that one doesn't quite work. I don't want to rule them out one by one. That just seems confusing. Now, I've got a 1 there. There's a 1 in one of these cells. Can I rule 1 out of here? Oh, can I rule 1 out of here? Definitely. Those are 6 plus yellow. We can't multiply them up by 1 and get to anywhere useful. So that's not a 1. So that's a 1. That's a 1. That's not a 1. At least that's given me all the 1s in the grid. First digit to be completed. All that tells me is that this is not a 1, which isn't quite what I wanted. But anyway. So 6 plus 4 would be 10. You'd have to multiply by 9, not allowed, to get up towards 91. 6 times 5 is 30, times 3 to get to just below 91. 3 is not allowed. This is the way to do it. 6 times 6 is 36, times 2 doesn't even get you close enough. I'm doing the wrong maths, so we'll try that again. Sorry. It's 6 plus 4. Now that was right, and I said you couldn't multiply by 9. 6 plus 5 is 11, times 8, not allowed, to get to 88. 6 plus 6 is 12, times 7, but plus 7 then. And that would be a clash. Ooh, we're getting somewhere here. I hope this works. 6 plus 7 is 13, but times 7 would give you 91 already. I've only got one possibility left. 6 plus 8 is 14, times 6 is 84, plus 7. And we've done it. That one works. That's the only way it can be. Isn't that bizarre? I'm sorry I didn't realise this was exactly what I should be looking at. But there we go. I've done it now. 4 and 5 remaining in the column. Now, has that fixed anything else? Probably hasn't. There's an 8 in one of those cells. That's 7. These final digits, they don't have to be odd every time, but they are likely to be odd every time. And the only way these two could both be odd is if that was 5 and that was 9. If they're not odd at the end of these Horner method cages, then they're even, and then this must be odd and must be multiplying an odd result from these 3 cells. I suppose maybe I need to think about these E's and what they can be. This is a complicated puzzle, isn't it? So if we had a 2 there, we'd have an 89 result. That's a That's a prime. It would have to be achieved by 89 times 1. And none of these cells can be a... Oops, not those cells. None of these cells can be a 1 anymore. So we are never having a 2 in the final E position. That's quite interesting. That means 2 in this cage is in this box is in one of those cages. Okay, now what about 4? That would leave 87. And that could be achieved by 29 times 3. Well, that can't happen here because we can't put a 3 there. Can it happen in one of these? With a 3 here, how would these do 29? That one could. 7, 4, 1, 3. No, that would need a 4 again. Okay, so that can't be a 4. Can this be a 4? 29 achieved here with a 3 there. No, we can't get up to 29 with that 2. So neither of those are 4 or 2. What about 6 and 8? I mean, this is complicated. If we had a 6 here, then we're reaching a total of 85, which is 5 times 17. I don't think there's any other way to do it. So that would be a 5. You see, that does work. And you'd be using a 5 with a 4. Okay, that's not a profitable line of approach. But you see, the trouble is I'm not good at finding the right lines. That one was available, and I just didn't realize we could approach it that way. I was wondering about whether 2 could be eliminated from those cells. I think that's a stretch. I don't see why that would be available at the moment. Oh. Right, I think I worked out 6 is a potential end cell. 8 probably isn't, actually. 8 in one of these end cells would leave the target to be 83, which is prime. And that would require these... It would require a 1 in these cells. Okay, so 8 is not possible. So these end cells, they can't be 2. It turns out that these 2 can't be 4, although 4 is theoretically possible. That one may be able to be a 4. And they can't be 8. So in these cases, they can be 6, 5, or 9 only. I think that conclusion is correct. So this is 5 or 6 only. I'm going to recheck 4, because that didn't give a prime. That gave 87. 4 there would need 3 there. Yes, we couldn't get to 29 here. That is right. Okay, so this is 5 or 6. So this is what I should work on. There may only be one possibility with a 5 and one with a 6. So if that is a 5, this group of cells gives 86. Oh, which is 43 times 2. And that can't be a 1 or a 2. That's no way. That has to be a 6. Oh, there we go. That's bizarre. Right, so these give 85. That has to be 17 times 5. That's a 5. These have to give 17. That is odd and is therefore 3 or 7. This can't be 2 times 5 plus 7, so that is a 3. And this has to be a 7. 2 times 7 is 14, plus 3 is 17, times 5 is 85, plus 6 is 91. And that is a slightly different collection of digits from here. And I mean, there we go. I mean, it's taken ages, but that's now a 4. This is an 8. That 4 is in an 11 pair, so that's a 7. This is a 5, 6 pair. Now, because that's 1, 5, 6, 8, 3, this cage must be 1, 4, 7, 8, 3. And these are a 5 and a 6 at the ends of column 2. Now, is there a point when this puzzle starts getting easier? I don't know, but I can put a 3 in the corner. That's 3 in the corner. That's 3 in the spotlight. It's really not in the spotlight because it's not taking part in any of these interesting cages. But that places 2 in the box. This is 4 or 5. That's the only place 9 can go in the box. And now these give a result of 82, which is 41 times 2. That is going to have to be a 2. These give 41, and therefore these give 40, and are a 5-8 pair, and now it is getting easier. Wow, this has been tough and interesting, and mathsy, very, very mathsy. That has to be an 8 in its box, so maybe I could do the rest by Sudoku and just check the maths if I was very lucky. That's unlikely. But that is a 3-6 pair now. And that is therefore a 5, and this is a 6. This now can't be 6, 5, or 8. Ooh, this is getting quite constricted. So we'll look at this one, where we get an 86 result from those 4 cells, which is 43 times 2. 43 is prime, so that's a 2, since it can't be a 1. These are giving a result of 43, and we're using 4, 9, and 7. Well, it's 4 times 9 plus 7. Yeah, the other one doesn't work. So 4 times 9 plus 7, and that one has worked. Oh, gosh, good. I'm feeling like it's easing up a bit now. That's a 5. This is an 8-7 pair. Now, 8 surely can't work here. That would give these, I didn't put the X's in, but never mind. That would require these to add up to, or give a result of 83, which is prime, and that can't be a 1. So that is not an 8, that's a 7. Now, these give a result of 84, which is a very composite number. But this can only be 3, 4, or 6 by Sudoku. I will come back to that. 84 has too many ways of working. That's not exciting to me at the moment when so much else is happening in this puzzle. That is 3 or 7. This one can't be 2. 5, 9, 2, 1. Oh, that's a 3-6 pair. So that is in fact a 7 there. Ah, now that's 4, that's 7. Yeah, this is getting easier. 7 there. Now, the digits up here are 2, 3, and 4. In fact, let's stick an 8 in the corner. So, there's only going to be one way that this works. And we're looking for a result of 90. That can't be 3, that can't be 2. So, if this is a 4, this is giving a result of 15, and that won't work. 7 times 2 plus 3 is 17, times 4 is the wrong number. So I think that is a 3. I hope this is right and works, and I'm going back to that if it doesn't. And then these have to come to 30, 7 times 4 plus 2, they do. Wow, 7, 4, 2, 3, 1. Okay, so that's good. That fixes 4 and 5. That fixes 6 and 5. Let's get rid of all the colouring in the grid that we supplied. And we're down to this. And let's do Sudoku. 7 and a 4, 5 pair. This is now an 8, 2 pair. That is a naked 5. That's helpful. 8, 6, 7, 9. Yeah, that's right. 4, 5. This is 3 or 6. We are not finished. Oh, that's a 2. Good. And this is 3, 4, or 6. And now we just have this one left to work out. With these 4 come to a result of 84. Now, if that's a 3, 6 pair, that's 18 plus 2 is 20, times 4 is 80, plus 7 is close but no cigar. So that is not a 3, 6 pair, so that must be a 4. Oh, there we go, 4. Let's just see what that does to the rest of the puzzle. Now, before I fill this in as a 6, which will be the final digit and complete the puzzle, hopefully, we've got 3 times 4 is 12, plus 2 is 14, times 6 is indeed 84, plus 7 is 91. It looks like a different cage to all the other Horner cages, and that is a 6, and we have finished. And that was crazy. Happy birthday, Mum. Well, indeed. Happy birthday, Carol. Fantastic. Thank you, not that it matters. That was a real mental workout in a way. I mean, I guess I was expecting to do some maths given the rule set, but I wasn't expecting to have to do that much mental arithmetic and kind of modulo maths all the time. Very clever. Very interesting. I don't necessarily want to do another puzzle like that too soon, but I really enjoyed it. So thank you as always for following along with me. Sorry if I bored you with the crossword stuff at the beginning, but there we go. Another Times Crossword Championship slips by. I will try again next year. Thanks for watching. I hope to see you again soon. Bye for now.